Salam sejahtera, we are from Group for CAPYBARU. We will be presenting a project with the title Heart Disease. My name is Alia Christina and my other two members are Melody and Cornelia.
Okay, so I would like to start the introduction. So our group get the data from KAGR, which is heart disease set. The heart disease is a life-threatening disease and addressing it should be considered a global health priority. The most common heart disease is coronary artery disease, which can lead to chest pain, heart attack, or stroke. So our aim to study this project is to understand what factors contribute to heart disease and how they relate to each other. Through the variables such as BMI, smoking status, and age, our goal is to discern their relative impact on the likelihood of developing heart disease. At the same time, we also hope to see which ones play the biggest role in predicting the heart disease. We are doing this in order to help those students to better prevent and treat heart disease. So, we are motivated to pursue this investigation by pressing need to reduce the worldwide burden of heart disease. So we take this data set from KAGR, which shows a good data. Yeah. Next is the data set introduced. Okay, so this data set we get from KAGR is collected by the Maxwell, who is a data scientist in Germany, and compiled by Manu Siddhartha. So this data set consists a very wide range of attributes, which consists of age, sex, chest pain type, resting blood pressure, serum cholesterol, maximum heart rate achieved, exercise induced angina, and class. So the code given that shown in the table here. Okay, next. Okay, this is the attribute that we use to select. So now I would like to give Tina to talk about it.
Okay, so I will be representing sex and chest pain type. For the sex, according to the National Institute of Health, heart disease or cardiovascular disease is often seen as a man-related disease when actually the risk of women getting it is actually higher than men. So, however, in the older generation, heart disease has remained the leading killer of women. Report says 55% of women in Europe dying is caused by heart disease. This may be related to the deficiency of the estrogen after women hit the postmenopause. So, for the chest pain type, according to the UMass Memorial Health System, chest pain, also known as angina, is typically defined as a severe or dull discomfort that extends across the chest, accompanied by sensation of tightness, burning, or aching. So there are four types of chest pain, which is type 1, typical angina, occurs when the heart does not receive adequate blood oxygen. The type 2, atypical angina, which makes a heart attack feels like a gallbladder disease. Next is the type 3, which is the non-anginal pain, refers to the pain that is not associated with heart disease. Finally, the silent angina, which is the type 4, asymptomatic, is a disease in which normal angina occurs without chest discomfort or pain.
Okay, so for the attribute of age, it shows the disease has a negative impact on the quality of life for millions of elderly people. As the people age increase, their risk of developing heart disease also increase. So the relationship is directly proportional. This is because when people get older, their large arteries stiffen, resulting in high blood pressure and hypertension. So elderly people are more sensitive to salt, leading their blood pressure to rise. Next, which is the attribute of cholesterol. Okay, then, so for this attribute, a healthy cholesterol level for adults should be under 200 milligrams per deciliter, while for children, it should be under 170. In this study, cholesterol level are recorded in the unit of mg/dl.
Okay, so I choose four variables in this project, and the first is maximum heart rate. According to Polar, maximum heart rate is the highest number of beats per minute your heart can achieve under maximum stress. Factors such as age, fitness level, stress, and medication like beta blockers can affect your heart rate. In this study, maximum heart rate ranges from a minimum of 71 to a maximum of 202 beats per minute. Next is the resting blood pressure. According to the American Heart Association, resting blood pressure measures the pressures in the arteries when the heart is at rest between beats, typically recorded after sitting quietly for at least 5 minutes. In this study, resting blood pressure is recorded in mmHg. Um, Furthermore, exercise-induced angina is also one of the variables. According to Harvard Health, exercise-induced angina is defined as pain in the chest that occurs with exercise, stress, or other activities that make the heart work harder. Mm, In this study, exercise-induced angina is represented as an integer variable, where 1 indicates the presence of angina and 0 indicates its absence. Last is the variable class. According to the Mayo Clinic, heart disease describes a range of conditions that affect the heart, including blood vessel disease like coronary artery disease, irregular heartbeats, congenital heart defects, disease of the heart muscle, and heart valve disease. A normal heart in this context refers to the in this study, the classification of heart disease is represented by the variable class, where 1 indicates the presence of heart disease and 0 indicates a normal, healthy heart. Uh,
Okay, next, we would like to proceed to the proposed data analysis. To achieve a comprehensive understanding of the relationship among various health parameters about heart disease, we propose an analysis utilizing selected variables and appropriate statistical methods. So, for me, I select the variable of age and cholesterol. The objective is to examine the relationship between age and total cholesterol level. The analysis for doing these two selected variables are used to sample hypothesis testing. The expected outcome is to determine whether there is a significant association between age and total cholesterol level. If the p-value is less than the significant levels, which is known as 0.05, the null hypothesis is rejected. This suggests that there is sufficient evidence to conclude that there is a significant difference in the total cholesterol level between age groups.
Next, I have select two variables, which is maximum heart rate and resting blood pressure to conduct correlation analysis. My objective is to examine the relationship between maximum heart rate achieved and resting blood pressure. And my expected outcome is by calculating the correlation coefficient between maximum heart rate and resting blood pressure, we can determine the strength and direction of the relationship. If the correlation coefficient is positive and statistically significant, it would indicate that as maximum heart rate increases, resting blood pressure tends to be higher.
Next is the sex and chest pain type. So to assess if a sex is a predictor of chest pain type, to test these two variables, we use the regression test. So the expected outcome is by performing a simple linear regression analysis, we can determine the relationship between sex and chest pain type. If the regression coefficient is statistically significant, typically p less than 0.05, it would suggest that at chest pain type, we can quantify the extent of this relationship through this regression equation.
Lastly, I am using the variable exercise-induced angina and class to conduct the chi-square test of independence. And I'm conduct this test to evaluate the independence between exercise-induced angina and class. And my expected outcome is by conducting a chi-square test of independence, we can examine if there is an association between exercise-induced angina and class. If the chi-square test yields a non-significant p-value, it would suggest that the exercise-induced angina and class are independent.
So, for me, I will present the two sample hypothesis testing between the two variables, which is age and cholesterol. At the same time, I also using R package to do the data handling. So, for the mean of age, it shows the value is 53.72017 and the standard deviation is 9.358203 and the mean same with the previous and the number of doctor is 1190. For the cholesterol, the mean is 210.3638655 and the standard deviation is 101.420489 and the mean is same with previously and the number also. So for the null hypothesis shows that there is no significant difference between age and cholesterol level, while the alternative hypothesis testing is there is a significant difference between age and cholesterol level. So by using the 95% of confidence level in the R programming apps, the test statistic can be calculated with the value of negative 17.9691 and the degree of freedom is 1189. So uh, the conclusion is we need to reject the null hypothesis. Hence, there is sufficient evidence to conclude that there is significant difference between age and cholesterol level. This is the uh, bell curve that show. Yeah.
Okay, so next is the correlation test. In this analysis, we will use the variable maximum heart rate and resting blood pressure to determine whether there is a linear relationship between maximum heart rate achieved and resting blood pressure at a 95% confidence level using person product moment correlation coefficient. Okay, so we are using R package like GridR, DPLYR, and ggplot2 for data handling and visualization. For instance, we have created a scatter plot to examine the relationship between resting blood pressure and maximum heart rate, aiding in our initial data exploration. So this is the visualized data in scatter plot using RStudio. And according to the scatter plot above, there is a weak positive correlation between resting blood pressure and maximum heart rate. It indicates that as resting blood pressure increases, maximum heart rate tends to increase slightly. However, there are several outlier and variability in the data. So first, we need to calculate the sample correlation coefficient using Pearson method. By using RStudio, we can know that the sample correlation coefficient R is negative 0.10135569, which indicates there is a relatively weak negative linear correlation between the maximum heart rate and resting blood pressure. Next, the null hypothesis for this test is P equal to 0, which is no linear correlation, and the alternative hypothesis is P not equal to 0, which is linear correlation exists. And we can calculate the test statistic using this formula. And by using RStudio, we get that the test statistic is negative 3.5116. And next step, we need to find the critical value. And from RStudio, we can get the critical value is 0.00046, and the p-value is equal to 0.0046. And hence, if test statistic greater than 0.0046 or less than negative 0.0046, we will reject null hypothesis. Otherwise, we will fail to reject the null hypothesis. And this is the graph that we get. Since the test statistic t equal to negative 3.5116, which is greater than the lower tier critical value, negative, we will reject the null hypothesis. In conclusion, there is sufficient evidence to conclude that there is a linear relationship between the maximum heart rate and resting blood pressure at alpha equal to 0.05.
Next, I will explain the regression test that we did. In this analysis, we will be using variables sex and chest pain type to determine whether the type of chest pain depends on the sex, using sex as the independent variable X and chest pain as the dependent variable Y. So we are using R packages like GridR and DPLYR for data handling. After using the RStudio, this is the scatter plot with jitter that we get. And then using the mathematical equation of population linear regression and estimated regression model equation, we will find the value of beta 0 and beta 1. And then using the RStudio, we can proceed to find the value of these two using this formula equation, which is B0 is 3 and B1 is 0.305 with 3 decimal places. So we can substitute the regression model equation using these two values, which is 3 plus 0.305x. Then from this equation, we can proceed to find the SST equals to SSE plus SSR. So using the R Studio, we will get these three value. Using these three value, hence we can get the coefficient of determination R squared, which is SSR divided by SST, which is 0.019. Then if we square root this value and multiply it by 100, we will get 13.784 percentage of the variation in chest pain type is related to variation in sex. Next, we can find the standard deviation of regression slope using this formula, and then using R Studio also, we can get the standard deviation of regression slope, which is SB1 equals to 0.06326. Next, you can proceed to find the t-test using this hypothesis statement. We can find the critical value using the alpha equals to 0.05 and the degree of freedom of the residual n minus 2 equals to 1188. So we successfully find the critical value, which is negative 1.962 and 1.962. This is the two value that we found from the R Studio. Hence, we can reject null hypothesis if test statistic is less than negative 1.962 or test statistic is more than 1.962. So to find the test statistic, you can use this equation formula. Using the R Studio, we get test statistic is 4.817. Then stating the decision, test statistic is more than the critical value. Hence, we reject the null hypothesis. There is sufficient evidence to prove that chest pain type is correlated to sex of the patient at alpha equals to 0.05. In the meantime, this is the linear regression model. Using this equation from the above, we can get from the image above, we can see the values of the intersection coefficient, intersect, and slope coefficient x. This is just the summary model that summarize the value that we found above, which is B0 is 3, B1 is 0.305, SB1 is 0.06326, the standard error is 0.9269, the degree of freedom is 1188, the multiplied R squared is 0.01916, and the p-value is 0.00001647.
Okay, so the last test that we choose is the chi-square test of independence. In this analysis, we will use a variable exercise-induced angina and class. And we are using the R packages like readr and dplwr for data handling. So the first step is to state the test hypothesis. Our null hypothesis is both of the variables are independent, while the alternative hypothesis is both of the variables are dependent. Next step, we find the critical value. So by using RStudio, the critical value x squared is 3.841459. Next, we will calculate the expected outcome. And this all the value also get from the RStudio. And next, we will calculate the test statistic value. When we calculate test statistic using RStudio, we will get test statistic x squared equal to 273.8777 with the p-value equal to 1.621 power negative 61. And last step is to state our decision. Since the test statistic value is greater than the critical value, it does fall within the critical region. Thus, we reject the null hypothesis. Therefore, there is sufficient evidence to conclude that there is a relationship between the variable exercise-induced angina and class at alpha equal to 0.05.
Finally, we can conclude that to start with, we noticed that the mean and standard deviation of age and cholesterol differed when we tested the two sample hypotheses. Thus, for the first two variables, we reject the null hypothesis. So, in reality, this implies that there is a clear distinction between these two variables. Next, for the next two variables, for the correlation test, there is also, we reject the null hypothesis again. Although the relationship is minimum at weak positive, it is still a negative linear correlation proven by the correlation coefficient R equals to negative 0.10135569. In reality, this means that resting blood pressure increases as maximum heart rate increases. This proves that there is a linear relationship between resting blood pressure and maximum heart rate. Next, for the regression test, we also found that sex tends to affect the type of chest pain one might have. Based on our linear regression model equation, we reject the null hypothesis. This proves that uh, men are more likely to develop chest pain type than women in younger age group. Thus, men are more exposed to heart disease. Lastly, for the last test, which is the chi-square test of independence, we found that there is a relationship between the variables exercise, induced angina, and class. Hence, we again reject the null hypothesis. This proves that both variables are dependent on each other. In real life, this would mean that people with exercise-induced angina are more open to developing a heart disease. So, in a nutshell, the likelihood of developing heart disease increases if the patient is an older woman or man, has exercise-induced angina, or has high cholesterol levels. We successfully use RStudio to execute test analysis such as two hypothesis testing, correlation analysis, regression analysis, and chi-square test of independence. This initiative has benefited our future by honing both our data analysis and research skill. We owe Dr. Sean millions of gratitude for his guidance and support on this project. That is all from us. Thank you.
Lastly, we got heart reference, um, which is in APA format. And okay, that's all from our group. Thank you.